Hi, hello, my dear students. Welcome back to my channel Kiran Physics Adharappu. Dear students, today we are going to discuss one interesting and very easy topic in electric charges and electric fields. That is intensity of electric field. This is part 4 video in electric charges and electric fields. So today we are going to discuss about intensity of electric field. Before this topic, first I want to explain about electric field. Do you know students what is electric field? I hope everyone have this experience. Okay. So listen to me. So first we have to consider any charge. This is Q is one electric charge. Q is one point electrical charge. Okay now. When you consider any charge around this charge, what happens? Always, if you observe clearly, around this charge always a electrical effect is distributed. This electrical effect is distributed into some region. Suppose this is one electrical charge, around this charge distributed some electrical effect. This region around this charge is called as what? Electric field. Okay now. That means if you consider any charge around this charge, electrical effect is distributed into some region. That region is simply is called as what? Electric field. Within this region, an electrical force or electrical effect is experienced on any another charge. Okay now. So how to understand? Is it electric field? Is not electrical field? Okay now, is it visible students? Is not visible. How can we understand is it electric field or not? So for example, if you consider any another charge, that is Q naught. So suppose this Q naught charge is brings into this region. So from the diagram understood, this Q, now this position of Q naught charge is behind the electrical field. That's why there is no electrical effect is experienced on this charge, because this is behind the electric field. But the same charge is brings into this region. Now it experienced electrical field because this is within the electrical field. Any electrical force or electrical effect is experienced on any charge, that is called as electrical field. That is a part of electrical field. I hope you understood what is electrical field. So from this point understood the space or the region around any charge up to which it has influence on any another charge. The electrical influence on any another charge, that is called as electric field. Okay now. So actually it is not visible, that's why it's not understood very clearly. But when you bring any another charge into this region, electrical force or electrical effect is experienced, then understood that is the part of electrical field. Okay now, this is the way to understood the electric field. So I want to explain one best example. I hope everyone very easily understood from this example, because everyone have this experience. What is the example? One best example of electric field is network. Network is one electric field. Do you know students? Okay now, within network all mobiles are working. Behind the network, mobiles are not working. That means mobiles are working within the network. That means network is one electrical field. Actually within this network only the electrical effect or the electrical force is experienced. So that's why this is one electric field. Have you understood what is electric field? Okay now. So listen clearly. I want to explain intensity of electric field. So now we are going to discuss one important parameter in electric field, that is intensity of electric field. Listen carefully all of you. So here for example this is electric field. In this electric field at any point here at any point, what is experienced electrical effect or electrical force is experienced. That means the experienced electrical force on Q naught charge is considered as intensity of electric field. That is a simple definition. That means electric intensity is nothing but electric force, the experienced electrical force on positive unit charge is called as electric intensity or intensity of electric field. Listen carefully all of you. First I want to explain about intensity of electric field. From the definition we have to construct one expression. From the expression very easily understood what is intensity of electric field. That's why I want to give one simple expression for intensity of electric field. Intensity of electric field, it is simply is called as electric intensity. Intensity of electric field is also called as what? Electric intensity. Electric intensity. Next, it is also called as electric field strength. Electric field strength, it is denoted by capital E. Electric intensity is denoted by capital E. Okay, now right. From the definition, what is the expression for electric intensity? The experienced electric force per unit test charge is called as electric intensity. That means from the definition, electric force per unit charge is called as electric intensity. This is a simple expression for electric intensity. From the definition, E is equal to F by Q naught. Here E stands for intensity of electric field. What is F stands electrical force. Q naught stands what? This is positive unit test charge. Okay na? Right. So for any another charge, if you want to expression for electric intensity for Q charge, what is expression for Q charge? Electric intensity is equal to F by Q is the formula. What is the expression for electric intensity for Q charge? F by Q. That means the experienced electric force on positive unit charge or any charge, that is considered as intensity of electric field. Okay now, right. After I hope you understood, this is very very important expression. So the definition understood in the form of expression. Electric intensity is equal what? F by Q naught. I want to explain the units. So it's SI unit. So its SI unit is what? Its SI unit is very easily understood from the expression. From the same expression, we have to understand what is the units of electric intensity. So from this expression understood the units of electric intensity depending upon the units of electrical force and units of charge. That means just substitute the units of electric force and electric charge, you get the units of electric intensity. Do you know the units of electric force and charge? What is units of electric force? Units of electric force is what? Newton. The units of any force is Newton. It is denoted by capital N. Capital N stands for Newton. What is units of charge? That is Coulomb. SI unit of charge is what? Coulomb. It is denoted by capital C. Don't denote by small c. Small c stands for centi, whereas capital C stands for Coulomb. That means Newton for Coulomb is unit of intensity of electric field. So we have one more unit for the same quantity, that is volt per meter. Volt per meter is also unit of electric intensity. We will discuss from our next lesson. So if you know the relation between intensity of electric field and electric potential, then very easily understood. That's why we will discuss from our next lesson. Okay, now just recognize this, that is volt per meter is also unit of electric intensity. Now I am going to discuss about the dimensional formula. So so we will discuss the dimensional formula of electric intensity. DF stands for dimensional formula of electric intensity depending upon the dimensional formula of electric force and electric charge. What is dimensional formula of electric force? The dimensional formula of electric force is mLT power minus 2. Everyone know this. What is dimensional formula of charge? Already in the previous class I explained the dimensional formula of charge is AT. That means mLT power minus 2 by AT is the dimensional formula of electric intensity. AT shifting into numerator, the expression is mLT power minus 3 A power minus 1 is the unit of, it is the dimensional formula of electric intensity. Okay now, so one more important point. Is it scalar quantity? Is it scalar quantity or vector quantity? Do you know, students? It is vector quantity, it is not scalar quantity. Why? Because electric intensity has both magnitude and direction. That's why it is considered as vector, it is not considered as scalar. From the definition also understood electric intensity, nothing but electric force. Electric force is vector quantity, not scalar quantity. That's why electric intensity also considered as what? Vector. Okay now. Have you understood? So that means you have to understood it is a vector quantity. It is a vector quantity. This is about electric intensity. Okay now. Now we are going to discuss about the expression for electric intensity. From the expression very easily understood what are the depending factors of electric intensity. Why? Because if you consider any charge, around this charge what is distributed? Electric field. In this region at any point electrical force is experienced. That experienced electric force on any charge is considered as electric intensity. That means here at different points, here, at different points electrical intensity is different. That means from this point at different points different electric intensities means it's depending upon the distance and also depending upon the source charge. That's why the electric intensity is depending upon the charge and the distance. These are the depending factors. That's why now we are going to construct the expression for electric intensity in terms of depending factors. Now I am going to explain the derivation of electric intensity. Okay na? Now we are going to discuss about the expression for intensity of electric field at a point due to point charge. Okay now. So here listen carefully all of you. First we have to consider one source charge. Suppose I consider one source charge at point O. This is O is one point. At point O we have to consider Q charge. Around this Q charge what is distributed? Imagine it, that is electric force or electric field is distributed. In this electric field at any point electric force is experienced. That experienced electric force on unit test charge is called as electric intensity. That's why from this Q charge we have to consider at distance, or we have to consider one more point P. Here you want electric intensity. Suppose you want electric intensity at point P. So we need the expression for electric intensity at a point P due to one point charge Q. That means that's why first I consider one point charge Q at O at a distance R. At a distance R, we consider one more point P. Here we need the expression for electric intensity. If you need electric intensity according to the definition, the experienced electric force on unit positive charge. That's why I consider one more charge, that is Q naught, positive unit test charge at point P. If you consider another Q naught charge at point P, some electric force is experienced on this q naught charge due to this source, due to electrical force of q charge. So now if you want an expression for electric intensity, how to it is possible? So first we consider q charge at point O at a distance r, consider one more point P. Here we consider another charge q naught. Now here observe clearly, we have two charges separated by some distance. Between any two charges always experienced a force of attraction or repulsion based on the Coulomb's inverse square law. In the previous topic I already explained that. That means now between these two charges some electrical force, this force of attraction or repulsion between any two charges is called as electric force. That means electric force is experienced. So here electrical force is depending upon the magnitudes of the two charges and distance between the two charges. Here we have two charges, one is q and second one is q naught. The distance between the two charges is r. That's why based on the Coulomb's law you get the expression for electric force. That's why first derivate in this way simply. So here listen carefully. We know that here from the Coulomb's inverse square law, what is electrical force here? Here we know that electric force is electrical force F is equal based on Coulomb's law 1 by 4 pi epsilon naught into q1 q2 by r square is the formula for electrical force based on Coulomb's inverse square law. Okay now students, do you know this formula? It's very important formula. Electrical force F is equal 1 by 4 pi epsilon naught into q1 q2 by r square is the formula. Okay now, but here whereas instead of q1 we have q, instead of q2 we have q naught, the distance between two charges is r. That's why what is electrical force is experienced between these two charges. Now therefore F is equal to 1 by 4 pi epsilon naught into, instead of q1 write q, instead of q2 write q naught. Q naught by r square is the formula. This is the expression for electrical force between these two charges. But we need the expression for electric intensity. Listen carefully. Here in the expression, one charge q naught is shifting into left side. And what is the expression here? F by q naught is similar to what is remaining equation? 1 by 4 pi epsilon naught into q by r square is the formula. Now the expression is, if you simplify in this way, F by q naught, just q naught is shifting into left side, F by q naught is equal 1 by 4 pi epsilon naught into q by r square is the formula. Here we know one important expression. What is expression here? Listen carefully. Here we know that from the definition of electric intensity. What is the expression for electric intensity from the definition? From the definition, listen to me, E is equal F by Q naught. This is the expression for electric intensity. In the expression, F by Q naught stands what? Electric intensity. Instead of F by Q naught, write E. Then what is the expression here? So from this, if you substitute instead of F by Q naught, E, therefore E is equal to, expression is 1 by 4 pi epsilon naught into Q by R square is a formula. This expression stands the expression for intensity of electric field. Have you understood? Okay now. So E is equal, what is the expression? 1 by 4 pi epsilon naught into Q by R square is the formula. This is the expression for electric intensity. Okay now. So here epsilon naught means what? Here this is expression for electric intensity in free space. In free space or in air medium okay, or in vacuum. So the expression is what? E is equal 1 by 4 pi epsilon naught into q by r square is the formula. But if you want to the same expression in any medium, what is expression for electric intensity? That is, suppose we have to consider E dash is equal to here, write instead of epsilon, not write epsilon, 1 by 4 pi epsilon into q by r square is the formula. This is the expression for electric intensity in any another medium. Here instead of epsilon stands for k into epsilon naught. That means E dash is equal to expression is 1 by 4 pi into k epsilon naught into q by r square is the formula. Okay, now this is the expression for electric intensity. In this expression here, E dash is equal, listen to me, here 1 by k into, remaining equation is what? 1 by 4 pi epsilon naught into q by r square. 1 by 4 pi epsilon naught into q by r square stands what? E. That means E dash is equal what? 1 by k into E means E by k is the formula. This is expression. K stands what here? Dielectric constant. So this is the expression for electric intensity. Right. Actually, from that equation, what are the depending factors of intensity of electric field? One is electric intensity directly proportional to charge. Electric intensity is inversely proportional to square distance and also depending upon the dielectric constant. These three are the depending factors of electric intensity. If you know these all values, understand what is the strength of electric field at any point in the electric field. This is about the electric field. Have you understood? Right. So electric field or electric intensity is a vector quantity. That's why we need to understand the vector notation. That's why I want to explain the vector notation. Listen carefully. Sometimes here given in vector form, the values are given, the position vector, the electrical force or everything is given in vector form, then asking electric intensity. That's why you need to understand the vector form. So vector notation. Electrical intensity denoted by E. Okay now. So electric intensity E is equal, general expression is what? Here actually 1 E is equal, listen to me, 1 by 4 pi epsilon naught into q by r square is the formula for electric intensity from the derivation. So in vector notation, that is 1 by 4 pi epsilon naught into q by r square stands r bar dot r bar. This is the magnitude of electric intensity. If our position vector is given in vector form, so then write here r bar dot r bar stands r square. So then you get electric intensity is equal 1 by 4 pi epsilon naught into q by r square. This is a magnitude of electric intensity. Suppose you want to the vector form. So in vector form, electric intensity E bar is equal to 1 by 4 pi epsilon naught into q by r square is only magnitude. But you want direction. Direction always indicated by unit vector. That's why here into one unit vector. Unit position vector is r cap. That means the electric intensity vector form is what? 1 by 4 pi epsilon naught into q by r square into r cap is the formula. It is also simplifying this way. This is the actual expression. But here we know one more expression from the definition of unit vector, that is r bar by r or mod r bar. Mod r bar stands what? R. That means r bar by r is the formula. Here instead of r cap, write this equation. You get the expression in vector form. E bar is equal to 1 by 4 pi epsilon naught into q by r square into r bar by r is the formula. So from this expression here, 1 by 4 pi epsilon naught into q by r cube into r bar. This is the expression for electric intensity. E bar is equal 1 by 4 pi epsilon naught into q by r cube into r bar. So r bar means what? This is position vector. If the Position vector is given in vector form, use the formula, measure the electric intensity. This is about the vector form. I hope you understood. Very simple topic. Here just recognize one expression from the definition. Recognize in the form of expression, that is E is equal to F by Q. The second expression is what? Electric intensity, mainly depending upon the charge distance. That's why expression is E is equal to 1 by 4 pi epsilon naught into Q by R square. If given in vector form, the magnitude of electric intensity, this vector notation is what? E is equal to 1 by 4 pi epsilon naught into Q by R bar dot R bar. Suppose you want vector form, this is one expression, this is another expression. This is in terms of unit vector, in terms of given vector. That's the difference between these two equations. That's all. I hope you understood. Okay. Right. Now we are going to discuss about the applications of intensity of electric field. Okay, na? So in we have mainly three important applications. Concentrate on these three important applications. Mainly the questions are asking on these applications. Okay, Machine should concentrate on these applications. The first application is motion of electric charge. Motion of electric charge in an electric field. Here EF stands for electric field. Motion of an electric charge. Motion of an electric charge in an electric field. This is the first application. So listen to me. Dear students, when any charge is in motion, here measurable quantities what? One is acceleration, second one is velocity, displacement, kinetic energy. These all are the measurable parameters. Okay, now that's why we have to construct the expression for acceleration and velocity, displacement, and what here? Kinetic energy. We will discuss these all parameters for motion of an electric charge in an electric field. Okay, now first I want to explain about the acceleration. So first one is, in this application, first one is acceleration. Acceleration due to electrical force, electric field, due to electric field. Due to electric field, what is acceleration of electric charge? Okay, now when electric charge is placed in electric field, an electrical force is experienced. When electrical force is experienced, force is always directly proportional to the acceleration. That's why that charge getting acceleration. That's why we need to discuss about the acceleration of electric charge. So for example, when Q electric charge is placed in electric field, some electric force is experienced. That electric force equation is what? From the definition of electric intensity, on Q charge, electric intensity is equal to what? F by Q is the formula. What is expression for electric intensity? Is equal to F by Q is the formula. From this expression, what is expression for electric force in terms of electric intensity? That is EQ is the formula. Most important expression here. Generally, based on Coulomb's law, we know the electric force equation, that is 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the expression for electric force in terms of given two charges. But sometimes asking electric intensity in terms of electric intensity. From the definition, E is equal to F by Q, F is equal to EQ. This is the expression for electric force in terms of electric intensity. The given values are electric intensity and charge. Then what is electric force? F is equal, EQ is the formula. But we need the expression for acceleration. What is acceleration? Force, write the force equation in terms of electric intensity. We know the expression for electric force in terms of we know the expression for electric force in terms of acceleration. Do you know the students? What is expression for electric force in terms of acceleration? based on the Newton's second law. What is the expression for F, electric force? Sorry, generally any force F is equal to, in terms of acceleration, is ma. This is expression for force in terms of acceleration. That's why instead of force, write ma is equal to eq is the formula. This is the formula. We need the expression for acceleration. That's why write as a subject a is equal to eq by m is the formula. This expression indicates the acceleration due to electric field. Due to electric field, a is equal to eq by m is the formula. Okay, now E is the intensity of electric field, Q is the charge, M is called mass of the charge. So this is about the acceleration due to electric field. Very easily. So you have to recognize this expression. Sometimes asking acceleration due to electric field. If you know this all values, substitute in the formula, you get it. Okay, now this is one application in motion of an electric charge in electric field. Now we are going to discuss about the velocity. Listen carefully. For example, if you consider one charge in electric field, initially the charge is at rest. Initially, listen to me, initially charge is at rest. Okay. At rest means initial velocity is what? 0. What is initial velocity when it is rest? 0. So you need the expression for velocity. What is expression for final velocity? From the first kinematic equation. What is the final velocity equation? Final velocity V is equal U plus at is the formula. What is final velocity? V is equal U plus at is the formula. So what is U here? 0. Then 0 plus what is A? Expression for acceleration due to electric field is EQ. Here in terms of electric field, EQ by M into T. That means here finally velocity V is equal to EQ by M into T is the formula. This expression indicates the velocity of charged particle in an electric field. It's very simple. Okay, just you know the acceleration formula, substitute it, you get it. This is from the first kinematic equation. We know the final velocity V is equal U plus AT. U is the initial velocity, V is the final velocity, A is the acceleration, T is time. Substitute these values, you get it. Okay, na? Right. So now we are going to discuss about the displacement or distance traveled by the electric charge in an electric field. So from the second kinematic equation, we know the expression for displacement. From the second kinematic equation, what is displacement equation? Displacement S is equal ut plus half at square is the formula. What is the expression here? Ut plus half at square. Initially it is at rest. That means U is equal what? 0. Here U is equal 0. Okay, now next what is A is equal here? A is equal EQ by M is the formula. Already we have constructed these two. Substitute in the formula. S is equal to 0 plus 0 into T plus half into A stands EQ by M into T square. 0 into T here. 0 into T is 0. That means half EQ by M into T square is the formula for displacement. This is expression for displacement of charged particle in an electric field. Just you know this. What is intensity of electric field? What is charge? What is M and T? Substitute in the formula, you get it. One more expression in this application. Sometimes asking kinetic energy when it is in motion. One more measurable parameter, what? Kinetic energy. So kinetic energy general expression is what? Kinetic energy. Do you know the expression for kinetic energy? Everyone know this equation, that is kinetic energy K is equal to half mv square is the formula. What is the expression? Half mv square is the formula. So here K is equal to half into m into v square. What is the expression for V? V V is equal to, already we have constructed. What is V formula? V formula is EQ by M into T is a formula for V. But here V square, that means EQ by M into T whole square. If you simplify it, you get half into this is M into E square Q square T square by M square. One M square cancel, finally E square Q square T square by 2M is a formula. This is expression for kinetic energy. Have you understood? Kinetic energy equation, displacement equation, velocity equation and acceleration equation. This is about the first application. I hope you understood. Just recognize these all expressions, so you have to attempt very easily. This is previous model, that's why students should concentrate here. Okay na? Right, now we are going to discuss one more application. The second application here, oil drop model. What is second application? Oil drop model. This is also a repeated model in JEE Mains and NEET exams. So here, what is oil drop model? Right. So if you consider one oil drop in an electrical field, suppose if this oil drop is in equilibrium, if the oil drop is in equilibrium state, then what happens here? So listen to me. For example, this is one oil drop. This is oil drop. Its mass is what? M. So when it is placed in electric field, suppose when it is in equilibrium state means the net force acting on the body is 0, that is equilibrium state. That means two equal and opposite forces acting on the body, then these two equal and opposite forces cancel to each other, then the net force is 0. That's then the body getting a resting position. That resting position is called as equilibrium state. For example, here this is one oil drop. Its weight is always acting what? Downwards. This is weight of the oil drop. When electric field is acting upwards, so then only this oil drop in equilibrium state. Suppose one in electrical field, which force is acting? Electrical force is acting. Electrical force is indicated by Fe. These two forces are equal and opposite, that's why they are cancelled to each other, then it is in equilibrium state. That means here when an oil drop in an electrical field, it is in equilibrium state. So then we have to construct one expression. So here at equilibrium state, total upward forces is equal total downward forces. This is the expression here. These two forces are equal and opposite, then they are cancelled to each other, then it is at equilibrium state. That's why we have to consider total upward forces is equal total downward forces. From the diagram, upward which force is acting? Electrical force. So that means to only one force, that is electrical force Fe. In downward which force is acting? This is called as what? Weight. This is called as weight. This is called as electrical force. This is called as electrical force. These two forces are acting. That means downward force is similar to mg is a formula. What is expression for electrical force in terms of electric intensity? We know this expression here, always electrical force F is equal to EQ is the formula in terms of electric intensity. That means instead of F you write EQ is equal to mg is the formula. This is the expression. Now m stands mass of the oil drop. Okay, now oil drop mass is not possible to measure directly, that's why it is sometimes given in terms of density. If given mass, directly use the formula, sometimes given in terms of density. That's why you want to understand the expression for the same formula in terms of density. What is the formula here? Listen to me. Density is equal to mass by volume. This is general expression, the ratio of mass to the volume. So mass by volume of the oil drop is in spherical shape. That's why its volume is 4 by 3 pi r cube. That means from this equation, mass write as a subject, that is rho into 4 by 3 pi r cube. This is a formula for mass in terms of density. Now substitute here. EQ is equal m, instead of m write density into 4 by 3 pi r cube is the formula. This is the formula here. So here sometimes asking radius, write as a subject radius, you get it. So if you know, into z also here, if you know this formula, asking any question very easily attempt. Recognize this formula. E is called intensity of electric field, Q stands charge, rho stands density of the oil drop. Here r is the radius of the oil drop, g stands acceleration due to gravity. This is one important and standard model in intensity of electric field, that is oil drop model. Okay, now I hope you understood. Right, we have one more important application, that is tension model or string model. Okay, now concentrate here also. This is also repeated area. Okay, now in tension model we have two expressions here. What is two expressions? In the first, listen to me. First one is electrical force is acting upwards. Electrical force is acting upwards is the first case. Second case is, this is, suppose we consider case 1. Case 2 is electrical force is acting downwards. These two are the applications. Okay, now so here, right, so tension model means if you consider any charged particle that is placed in the electrical field. So here this is one charged particle, it is suspended by string. This is one rigid support. So this is one string attached to the any charged particle or oil drop or charged particle. So then here, when it is suspended by string, a tension force is created in the string. So one force is acting, tension force. When it is placed in the electrical field, electrical force also acting. Which forces are acting here? One force is acting, tension force. This is T. It is acting in this direction. One more force is acting, what? Weight mg. Mass of this charged particle is m, then mg is the weight. Weight is acting always downward. It is acting towards the center of the earth. This T stands for here. Tension is acting. It is acting upwards here. Suppose when it is placed in the electrical fields, electrical force also acting, that is acting support upwards. Fe stands for electrical force. This is called electrical force is acting upwards. Then what is expression here? So listen to me. Always it is in equilibrium state. It does not move upwards, downwards, because these upward forces and downward forces are equal and opposite. They are cancelled to each other. Then it is in equilibrium state. When it is in equilibrium state, total upward forces is similar to the total downward forces. Use the concept, you get the expression. Listen to me. From this point here, total, when it is in equilibrium state, total upward forces is equal to total downward forces. This is a point here. What is upward forces? Two forces here. One is T, second one is Fe. T plus Fe is equal mg is the formula. T plus, what is Fe stands electrical force equation in terms of electric intensity? Already I explained that is EQ, that is called mg is the formula. You need the expression here, asking tension in the string, expression for tension T is equal, what is formula here, mg minus EQ. This is most important expression here, asking tension in the string. Use the formula measure. M is mass of the charged particle, G is acceleration due to gravity, E is electric intensity, Q is the charge. This is one case. In the second case, same. We have to consider one rigid support. So suspended one charged particle. When suspended charged particle, here one force, tension force is acting in the string. It is opposite to the weight. Weight is acting downwards, it is acting upwards. But now electrical force is acting downwards, means this is electrical force direction. Now also sum of upward forces is equal sum of downward forces, means total upward forces is equal to what? Total downward forces. This is the expression. Only tension force is acting upwards. Downward two forces are acting. One is weight, second one is electrical force. Electrical force equation is what? Always in terms of electric intensity, that is EQ. That means now tension in the string is what? Mg plus EQ. That's the difference here. Mg minus EQ, here Mg plus EQ. Now tension in the string is more to compare this case. That's the difference between these two cases. This is also previous repeated area. Have you understood? Okay. So dear students, follow these all applications very easily understood. So we will discuss our next concept from my next video. Thank you. Bye all of you.